In this video, I will use one of the workflows of a visual usability checker to measure the cognitive load score of a chosen design. Our aim is to reduce cognitive load. This will make the layout easier to understand while keeping the call to action very visible. Its visibility must stay strong and ideally improve. A higher score means a heavier cognitive load. Running the desktop test, the score is 81, which is high. Our goal is to lower this number so the design feels clearer and easier to use. The score indicates how much mental effort a user needs to process the layout, how quickly they comprehend it, how easy it is to read, and how smoothly the message comes through. The cognitive load map displays where the design creates the most effort. Brighter yellow areas represent high effort. The background image is the biggest source of cognitive effort, followed by the text block. Breaking down the score, the main factor is detail density, which makes up nearly 50%. Too many small details and an intense background distract from the content. Reducing these should lead to better results. Other factors that add weight include visual entropy, which measures how chaotic the design feels, color complexity, which involves too many tones, and attention distribution, which indicates uneven focus. Simplifying the design, especially the background, is the best way to move forward. Since the image causes the most load, we'll focus our changes there while keeping an eye on CTA visibility. To do this, I'll use another workflow of the visual usability checker called iterative testing. By making adjustments and checking each version, I can see how attention shifts and then retest for cognitive load. The first change is darkening the image overlay so the text stands out more clearly. I also refined the typography. Plain fair display works well for headings but not for paragraphs, so I switched the body text to quicksand, which is cleaner. I unified the font sizes for consistency, which reduces visual chaos. I improved spacing as well. I increased the line height in the subheading and enlarged the CTA button with more padding. This gives the CTA more room and makes it more prominent. The attention analysis shows the heading draws slightly less focus, but the button remains strong. Since the CTA is our priority, this is a positive result. Finally, I remove the full background image and incorporate a smaller one on a black background. The design looks much cleaner, and attention scores show that both the heading and the CTA now stand out more. After running the analysis again, the original score is 81, the second iteration is 69, and the third is 56. Each tweak, including darker overlays, simpler backgrounds, better fonts, and cleaner spacing, reduced the load and improved clarity. The main issues were detail density, background intensity, and chaos. Addressing these step by step improved readability and balance. Later versions even increased focus on the CTA. The design now feels calmer and more user-friendly. When comparing results, both the second and third iterations work well. However, the third version combines the lowest cognitive load with the strongest CTA attention. The data confirms that the third version is optimal. Iterative testing shows its importance. Instead of making random guesses, we adjust, analyze, and validate each step. This approach highlights the benefits of combining cognitive load analysis with iterative testing. The end result is a cleaner, more consistent design that looks better, works better, and guides users effectively.